Hey guys, I wanted to give you one more example problem if it would help you for studying for our first 2D forces test. And this is going to be it, and I thought maybe me walking through the steps would be one last thing to help you just know what they are. So it says you push a car with a 300 Newton force directed at 17 degrees below the horizontal. It gives you a resistance force. So this would be like if you're pushing a stalled car. And you're probably not getting down and pushing straight, you're probably pushing kind of down on it. So that's how we're going to deal with the angle. This problem, like every other, follows the same steps we do for 2D forces. Number one, draw a picture. Not the best car, but that's okay. Here's our friction force parallel to our road. Of course, we have a normal force, and we have gravity. And here is our pushing force. So that's the hardest part of the problem, is getting a decent picture. We now have to generate a sigma fx and a sigma fy equation. We may not need both, and in this case, I think we only are going to end up needing the horizontal. But let's do both. Sigma fx equals ma. So what goes in there? Any force that can be described as left or right. And in this case, that's Fp and FFR. Of course, it's not all of Fp, because Fp is also partially down. So we're going to put an X on it to signify just the part of Fp that's going to the right and not the part that's down. We could do the same for the Y. So Fn would be up, so positive, minus Fg, and then minus Fp, the part of Fp that's down. So we'll call that Fpy. Honestly, if you can do this part, you're kind of home free. That's the hard part. The next step is any force that's not purely left, right, or purely up, down. We use trig to break it down. Obviously, that's just Fp. So we find the part that's left, right. We'll call that Fpx. The part that's up, down, that's Fpy. And they told us that this angle was 17. So you can find both of these just using sine and cosine. So I'm going to just stick with x for now. I don't think I need y for this problem. But in general, you would do both the sine and the cosine. Since Fpx is the adjacent side, I'm just going to worry about cosine. And the cos of 17 is going to be Fpx over Fp. So just solving for Fpx by itself, I'm just going to multiply both sides by Fp, and I get Fp cos 17 equals Fpx. I can now put that over here in this equation. It gave me what the frictional force was. I know the mass of the car. So the only thing I don't know is acceleration. So now, once I do this, I'll be able to solve for that acceleration. Notice I didn't have to do anything with the y equation. Sometimes you do and sometimes you don't. Typically what I would probably solve for here would be the normal force. To solve the second part of the problem, how long does it take to go 5 meters? I would finish this by getting the acceleration. And once I had the acceleration, I would look for something that has distance, time, and acceleration in it. And we know that equation, of course, is x equals xo plus vot plus 1/2 at squared. And I would plug into that and solve the problem. I'm going to stop this here so you don't have to just sit there watching me do math, but there'll be a link on Google Classroom to the solution for the problem.